How long will humanity persist in the universe? 70,000 years ago, the human population was nearly wiped out by the supervolcano Toba. What I don't need to mention is that another similar eruption is likely to occur within the next 10,000 years. A supervolcano is just one of the events that could threaten the survival of human civilization. The future is full of dangers. In this video, we will explore the major threats to human civilization and how humans can address them, prolonging the life of our civilization. One of these threats is capable of destroying even a civilization that has expanded across a galaxy. So let's start. Time is limited. Part 1: Surviving on Earth. The first threat to humanity is essentially just around the corner, in the consequences of climate change caused by human activities. The comments section of this video will be fascinating. The increase in the planet's average temperature means more energy for the atmosphere to use in extreme weather events, from intense storms to increasingly common floods and droughts. This destroys infrastructure and the human capacity to produce food, crucial to our survival. In addition to the short-term effects, global warming could result in the melting of the Wilkes subglacial basin, raising sea levels by 3 to 4 meters over the next 10,000 years. The great danger is not that climate change will kill all human beings at once, but rather that a much hotter planet is incompatible with the existence of a technologically advanced civilization. If the worst-case climate change scenario comes to fruition, our industrial and scientific capacity could be destroyed. Without the ability to create new technologies, we will be vulnerable to inevitable extreme disasters. Overcoming this challenge means preparing to deal with and mitigate the damage from extreme weather events and changes to the planet. Additionally, learning to utilize cleaner forms of energy, especially nuclear fusion, would be crucial. Mastering nuclear fusion would completely change the logic of energy production in the world, offering a clean and perfect energy source that would also drive large-scale space exploration, essential for the long-term survival of our species. If we learn to deal with extreme weather events, we will be guaranteed survival for millions of years, or at least until we face the first more extreme event, such as the fall of a large asteroid or the eruption of a supervolcano, such as Yellowstone. Supervolcanoes are serious problems that can cause immense destruction immediately. However, the main danger lies in the ability to drastically alter the planet's climate, causing artificial winters that can last for years, affecting human ability to produce food. For civilization to last, it is crucial to have mitigation and reconstruction plans to prevent such an event from causing the collapse of everything that has been built. It is worth noting that threats of this type do not necessarily affect humanity in our current lifetime, but when thinking about long periods of time, the statistics are not in our favor. For example, in about 100 million years, it is almost certain that another impact will occur with similar intensity to the one that wiped out the dinosaurs. Any trace of us will be gone by then, but the possible living humans will have to deal with the problem. Fortunately, we are already learning how to deal with asteroids through NASA's DART project, which involves colliding a probe with an asteroid to successfully change its trajectory. We also maintain a catalog of the most dangerous asteroids and constantly monitor these objects. The most dangerous times for a fatal impact are the next few centuries, while we still do not have full ability to deflect asteroids. 1 million years from now, the solar system will receive an unsolicited visit. The star Gliese 710 will pass through the solar system. This invasion will cause extreme gravitational disturbances in comets in the Oort cloud, a cloud of comets at the edge of the solar system. Some of these comets will be redirected into the inner solar system, resulting in an unprecedented comet shower. As a consequence, there is a high chance that at least one of them will collide with Earth. Furthermore, there is a possibility that this event could eject Earth from the solar system, turning our planet into a space orphan. If this happens and we don't have space colonies, it will be the end of human civilization, which, up until this point in the video, will have lasted for maximum 1 million years. This stellar visitation will not be the only catastrophe to threaten life on Earth in the next million years. More extreme events are sure to happen, such as the progressive warming of the Sun, making the Earth less and less habitable until, around 1 billion years in the future, the average temperature reaches approximately 47 degrees Celsius. If humanity wants to last longer than 1 billion years, we will need to have an escape plan from Earth. But what if humanity ends today? The bad news is that the internet will go down after a few days, taking with it all the knowledge accumulated over centuries of humanity's science. We will need to leave Earth behind. Part 2: Colonizing the Solar System. If we want to survive as long as possible in the universe, we need to leave Earth and establish independent colonies on Mars, the moons of Jupiter, and perhaps even in space using generational ships. This would drastically increase humanity's lifespan, allowing us to last at least until the end of the solar system, predicted to be around 4 or 5 billion years from now. However, there is an unforeseen threat: gamma-ray bursts. These dramatic and energetic events can extinguish life across an entire solar system in the blink of an eye. When a large star, more than 8 times the size of the Sun, uses up all of its fuel, it explodes in a supernova, releasing huge amounts of energy, including extremely dangerous gamma rays. While a supernova close to the Sun is unlikely to emit the most damaging gamma rays, there is a possibility that our solar system could be hit by at least one gamma-ray emission from a supernova within 500 million years. There is no known solution to this problem. If a gamma-ray burst hits the star system, it will be sterilized almost instantly. Colonizing the solar system would buy a few 100 million years of survival, perhaps even 1 billion years if we are very lucky regarding the timing of the gamma rays. But even if life in the solar system can't survive this, humanity can, as long as we decide to live beyond the solar system. Part 3: Colonizing the Galaxy. If we master spacecraft powered by nuclear propulsion, especially nuclear fusion, it will be possible to visit the nearest stars within a human's lifetime. However, these trips will not be short and will likely take decades. The goal is to take enough people to live long and prosperous lives outside the solar system, reproducing to ensure the continuity of the species. Colonizing the galaxy effectively and creating independent colonies in the solar system will be an immense technological challenge for which science still has no solution. An alternative is to use generational ships, which are societies within ships, carrying all of humanity at once, along with everything they need to survive: food, water and energy sources. However, the realistic feasibility of building a generational ship is still uncertain. Other alternatives include solving complex scientific problems, such as making humans biologically immortal by eliminating aging and death from disease, or exploring cryonics to send large dormant populations to other stars more efficiently. Both scenarios, however, depend on technologies that may not be possible. The ideal version of space colonization would be to solve the difficult challenge of consciousness and learn to upload human minds into machines. If we reach the galaxy and become a civilization that colonizes other stars, humanity will become practically indestructible. However, there is a phenomenon that can affect an entire galaxy and threaten humanity: galaxy collisions. In about 5 billion years, the Andromeda Galaxy will collide and merge with the Milky Way. The danger here is a radical version of a star's visit to the solar system. A collision of galaxies will cause extreme gravitational instability throughout the Milky Way, potentially ejecting entire star systems into the void of space. If, at this point, humanity only has colonies on a few stars around the galaxy, there is a considerable chance that they will all be affected by the collision. Ideally, it would have colonized large portions of the galaxy in the next 5 billion years. Come on, guys, there's time, and with patience, maybe even it is possible to reach some small dwarf galaxy that orbits our Milky Way. If we conquer the galaxy, we will receive the greatest prize in our lifetime as a civilization: the ability to inhabit the universe for the entire age of stars, which means 100 trillion years of prosperity. We have reached the last stage of survival. Part 4: The Dark Age. 100 trillion years is an incredibly long time, but it too will pass. In 100 trillion years, there will only be a few hundred stars shining in the galaxy. Our galaxy, at that point, will no longer be the same. It will be a true giant monster resulting from the merger of all the galaxies in our local group. Once the last stars go out, there will be no new stars and no useful energy to be used in the universe. If humanity reaches this point unprepared, it will mean our extinction along with the last stars. To go beyond and inhabit the post-star universe, the attitude of human civilization will need to change. The focus should be on preserving hydrogen for use after the star's natural end of life. If the first step to survival is to expand, the next step is to prevent stars from burning through their fuel too quickly. This attitude would literally change the history of the universe, buying time so that humanity can exist even after the stars go out. Perhaps the last 100 stars shining in the galaxy are humanity's last refuges, but refuges that will not go out anytime soon, because humans have saved all the remaining hydrogen in the galaxy for these 100 stars. Or better yet, humans saved all the hydrogen to utilize the most efficient energy source known in the cosmos, black holes. Nothing generates energy at scale like throwing matter into black holes. However, to harness their energy, we will need to learn how to build a cosmic dam. We will have to use the movement of gas falling into the black hole as an energy source. Furthermore, we will also have to capture the light emitted by the accretion disk around the black hole to somehow generate energy with it. These disks can shine much brighter than stars. They produce energy extremely efficiently. Living around a black hole and using it as an energy source would likely maximize our lifetime in the universe. That said, black holes will continue to exist for trillions and trillions and trillions and trillions and trillions of years. If we can inhabit the universe for a fraction of that time, it will be a tremendous success. In short, the lifespan of our civilization will depend on how far we get into the universe. If we never leave Earth, we are unlikely to last much longer than a few million years. If we reach the solar system, our lifespan jumps to almost 1 billion years, and conquering the galaxy would buy us hundreds of trillions of years or more, depending on how much discipline we have to save resources. And you, how long do you think humanity will last? How old would you guess? Thank you very much, and until next time.